Welcome back, students. Hope you all are doing well. Now in today's session we will be studying sorting algorithms. Let us first understand what do we mean by sorting. Now given a set of n elements, for example array or set of words or set of anything like a number of elements are there in a set and you have been provided with that set. Now suppose that there is an order relation that can be set across the elements. Now the goal is to arrange the elements in any particular order, say ascending or descending. Now here we'll have to start given a set of n elements. We'll have to start by arranging the elements in a particular order. As you can see here, the number of elements are as given here: 1, 23, 2, 56. Now if we carefully look at this series of elements, they are not in either ascending or descending order. So this has been given to you and you need to provide either an ascending ordered list or a descending ordered list. This means you need to arrange the elements in the order of their increasing or decreasing in number. Okay, so the end product you should get here is somewhat this. It means your elements should be in arranged in a proper manner. So this is the goal. Now sorting by comparison. The basic operations involved in this type of sorting technique is comparison. So here you are comparing the data elements. So one of the elements you are considering at a time and you are comparing it with the other elements in the given list and try to find the difference if you are arranging it in a particular order. You need to replace their places so as to get a sorted list. So here sorting by comparison includes exchange mechanism, insertion, selection and enumeration. We'll have a look at it one by one. Now sorting by comparison, first exchange. In this mechanism, if two elements are found to be out of order, they are arranged. The process is repeated until no more exchange is required. It means that the two elements, if they are found to be out of order, that means if they are not in a proper order, then you have to interchange their places. So here you are exchanging their places and you repeat this process until no more exchange is required, until all of the elements are now in a sorted order. Now example of this sorting by comparison includes bubble sort algorithm and quick sort algorithm. Now sorting by comparison having another mechanism as insertion. Here from a given list of items, one item is considered at a time. Given a list of items, you'll be considering one item at a time. Now this item chosen is then inserted into appropriate position related to the previously sorted items. The item can be inserted into the same list or to a different list. Example of this kind of mechanism includes insertion sort. Next mechanism is selection. Now in this, first the smallest item, either you select a smallest item or largest item, whatever it is located and it is separated from the rest of the elements in the list. Then the next smallest or next largest element is selected and it is again separated from the remaining elements of the list, and this process continues till you get a sorted list. Example of this kind of mechanism includes selection sort as well as heap sort. Next is sorting by enumeration. Here two or more input lists are merged into an output list. And while merging, the items in the input list is chosen following the required sorting order. So while merging the input list, while merging the two lists, we'll have to be very careful that they, after merging, they form a sorted order list. Example of this kind of mechanism includes merge sort. There is another mechanism which is known as sorting by distribution. Now here no key comparison takes place. We're not going to compare the keys here or the items. All items under sorting are distributed over an auxiliary storage space based on the constituent element in each, and then group them together to get the sorted list. So the distribution of item based on the following choices. First is radix. An item here is placed in a space decided by the basis, or we can call it as radix, of its component with which it is composed of. Second choice is counting. Here items are sorted based on their relative counts. And the third one is hashing. Here items are hashed, that is dispersed into a list based on the hash function. First we'll see in detail bubble sort algorithm. Now this bubble sort algorithm is considered as the simplest algorithm. The basic idea behind is to set a flag. Initially we set a flag as false. We set the flag as false. Then traverse the array. Given a list, we are considering the given list as array of n elements. First we set a flag as false, then we traverse the array, and compare two elements within the array. See, we traverse the array and compare the two elements within that array. First two elements we are comparing initially. So if E1 is less than equal to E2, it's okay. That means the first element, if it is less than the second element, the following element, then it is okay. Nothing has to be done here. But if E1 is greater than E2, that means the first element in the array is greater than the second element, then we need to switch their places. We need to swap them. That means we need to interchange them. So whatever the value at this position E2, it will go to the first position, and the value at E1 will come to the second position. Okay, and here we are setting the flag as true. Then if flag is equals to true, we again switch to, if flag is equals to true, we are again switching to step number 1. See, if flag is equals to true, so here we have set the flag as true. So we again go to step 1, and then we continue from the next two elements for comparison. And this process continues till all of the elements within the array have been compared. So here we have the sorting code using bubble sort. See here, initially we have taken here a temporary variable. We have initialized a looping, two loops here, outer loop using I variable and inner loop using J variable. Here we are comparing both of them. See, AR is our array having n elements. We are comparing them, first element with the next element. If so, if it is greater, then we are swapping them and we are coming out of this. And this loop continues till all of the array elements are sorted. To better understand, let us see this with the help of a given series of elements. So just assume that this is the given series of elements here. So initially we will begin with the comparison between these two elements, right? We'll begin with the comparison between these two elements, 1 and 23. So obviously 1 is here less than 23. So we will not swap them. Next time what we will do, we'll compare 23 with the next element, that is 2. So 2 is less than 23. So this swapping has been taken place. Right? Now, now we will, now first two elements have been sorted. Now we'll proceed towards the third and the fourth element. A comparison is carried out. Right here, comparison is carried out. Since we have swapped them, now here is the next element, 56, and 9 is under comparison. So we found that 9 is smaller and it takes place. Right? Then what, here comes 56. So 56 and 8 will be compared and then swapping will take place. And this process continues for the first traversal. Then we start again with the initial element and we start comparing it again. Right? Here you can see we start comparing it again. Now at this time we found that nothing has to be done here, but here there is a problem. 9 is smaller than 23, so swapping will take place as 23 takes the place of 9. So here 23 and 8 is compared in the next iteration and is swapped again, and then 23 and 10 here in the next iteration we are comparing these two elements. As we found that 10 is the smaller number than 23, swapping will take place. And this is the second traversal. If needed, if after doing so we didn't get the sorted list, then we have to start it over again. And this continues till all of the elements in the array have been sorted. Now this is the implementation of bubble sort with an array. Here is the source code, you can see, very simple. Now the time complexity for bubble sort is, in case you are having in the best case, the time complexity is big O of n, where n is the number of elements in the given array. In average case, it is, in average case means, in best case means, here you found that most of the elements in the given array list are already in a already in sorted manner. They occur in sorted manner. Okay. In average case, you are having, that means half of the given list is sorted and half of the given list is unsorted. Half the elements are sorted, half the elements are unsorted. So in average case, you'll require n square time for sorting. And in worst case, that means all of the elements, they are arranged in exactly opposite order. That means if you want the list to be sorted in ascending order, the given list is in descending order. So it will take n square time to sort the given list. Now next algorithm here is quick sort. Now at every step we select a pivot element in the list. Pivot is an element we are selecting. Based on this we will be doing the comparison, and this pivot element is usually the first element in the given list. We put the pivot element in the final position of the sorted list. then all the elements less than or equal to the pivot elements are to the left, and all the elements then greater than the pivot elements are to the right. From the figure, you will be able to understand how this will take place, right? So the first element will be considering as the pivot element, and we'll be doing comparison. We'll try to find if this pivot element will try to scan to the right till the end of the list, and we'll try to find an element which is smaller than the pivot element. If we found, then we will swap it. Then in the next scan, we will scan from from the right towards left, and we'll try to find the an element which is having greater value than the pivot element. If found, it will be swapped again. And this process continues. Let us understand this with the help of an example. So see here we have an example given as 44, 33, 11, 55, 74, 90 and so on. Now initially we are considering this as pivot element, the first element in the given list, that is 44. So let 44 be the pivot element, and scanning done from right to left. So we will begin scanning from right to left. Okay, we'll scan all the elements in this direction, and we will compare all the elements while scanning in order to find an element which is smaller than 44. So here we will find, see here, we'll try to find the element from right to left. Okay, so right to left, this is the order of scanning. Here, and we'll try to find, we'll scan in this direction, and we'll try to find an element which is smaller than 44. So here we find that 22 is smaller than 44. Hence in the next step we will swap 22 with 44. Okay, so here we get, after swapping we get this kind of list. Now here we will compare 44 to the left side element, and the element must be greater than 44, right? So pivot is 44, and we will be from this left to right, we will scan and we'll try to find an element which is greater than 44. So here we found 55 which is greater than 44. Hence again we'll swap the two elements, that is 55 with 44, we will swap here. So we'll be getting this kind of list, right? Then continuing the step here again, and this process continues. Next time we will try to find an element which is sorry, see here we found 55 is greater than 44, hence the swapping took place. Then while scanning from here, uh, from here till here, we'll try to find an element which is smaller than 44. So we found 40 is smaller than 44, and the swapping will take place, right? So here we will get this kind of swapping list. 40 is here, 44 is here, and then next time we'll swap 77, because we are trying to find, in this scan we try to find an element which is greater than 44. So here we found 77 is greater than 44, hence we swap the two elements, getting the list as this. Okay, now the elements on the right side and left side are greater than, now if you carefully look at this, we are getting two things. all of the elements towards this side is greater than 44 and all of the elements towards the left side is less than 44. And now we are getting two sublists. We are getting two sublists. The sublist 1 consisting 22, 33, 11, 44 and the remaining sublist towards the right side of the element 44. And these sublists are sorted under the same process. Now we have to apply the same procedure for these two sublists. Okay, so you can see they are sorted side by side. We are applying sorting algorithm over this area also and over this sublist, right? So here again, starting with this as the pivot element, we try to find, scanning this side, we try to find an element which is less than 22. So we came across 11, hence it is swapped. Then while scanning from this direction, we came to know that 22 is greater than then 22 again here, and then this becomes the first sorted list. And towards this side also we'll consider this 90 as the pivot element and we'll swap accordingly. So this will give you again sublist here. In this fashion, the complete array is sorted using quick sort. The sorting algorithm using priority queues. Now remember priority queues. So the sorting algorithm make use of queues to store this to store the elements temporarily in order to arrange the elements in a particular order. And we know that priority queues are the queues where DQ, double-ended queue operation, always removes the element with the smallest key using the remove minimum operation. The algorithm that are making use of priority queues are two here: selection sort and insertion sort. Selection sort insert elements in an unsorted sequence and remove them one by one to create the sorted sequence. Whereas in insertion sort, elements are inserted in a sorted sequence. See, there is a difference. In selection sort, we are inserting the elements in unsorted sequence, right? Whereas in insertion sort, we are inserting the elements in sorted fashion and then remove them one by one to create a sorted sequence. First we'll see the working of selection sort. Now here the smallest value among the unsorted elements of the array is selected in every pass and inserted to its appropriate position into the array. Here we begin with the smallest element among the unsorted. We are assuming that the given list is unsorted. So we begin with the smallest value here. That means we pick up the smallest among all the elements in the array or in the given list. And with every pass, we insert it to the appropriate position. So this is again a simplest algorithm and it is an in-place comparison sorting algorithm kind of mechanism. Now mechanics here, we see an array is divided into two parts. First is sorted part and another one is the unsorted part. Now initially the sorted part of the array is empty. See, as I said that in selection sort we insert the element in an unsorted sequence and then we remove it one by one and then place them into proper positions. So initially the sorted part, as it consists of two parts, one is sorted, another one is unsorted. So initially sorted part is empty and unsorted part is having the complete list of the elements that needs to be sorted. The sorted part is placed at the left while the unsorted part is placed at the right. The process continues until the array is entirely sorted. Now this selection sort is generally used when when the given element list is small that needs to be sorted, and swapping cost doesn't matter. In that situation also we'll be making use of sorting and selection sort algorithm. And when it is compulsory to check all the elements in the given list. So if the given list is small and where swapping doesn't matter, and it is also necessary to check all the elements in the given list, then only then we will be using selection sort algorithm. Let us have a look at an example. Now let the given array elements be as shown over the slide. You can see this is the given list of array: 12, 29, 25, 8, 32, 11, 40. It is totally unsorted. Now for the first position in the sorted array, as this is selection sort, the entire array is to be scanned sequentially. So initially we will scan the complete given list sequentially one after another, and we'll try to find out the smallest element, as we need to begin with the smallest element here. So we found that 8 is the smallest element among all the elements, right? Now at present 12 is having the first position. Element 12 has taken the first position in the given array list, whereas the smallest element found is that of 8. Now here, as 8 is smallest, and whatever element at the first position is there, we will be swapping it with 8. Okay, so here 12 will be swapped with that of 8, right? So 8 will come here and 12 goes at the position of 8. As you can see, we have sorted this. Now for the second position, at the second position we are having element 29, right? And we again scan sequentially the rest of the items in the unsorted. So we know that now 8 is sorted, so by the time we'll ignore this 8, we will start with the next element. So this part is unsorted. Okay, this part is sorted and this part is unsorted here. So we'll begin at the first element in the unsorted list, and we will, after scanning, we find that 12 is the second lowest element, right? So here, while scanning, we'll keep in mind the second lowest element after 8. So in this particular list, we know that 12 is the second lowest element, and 29 is the first element of the remaining unsorted part. Okay, so here we will swap it. Now after swapping, 29 goes here and 12 comes after 8. Now this part becomes the sorted part, and the rest of the elements are belonging to unsorted part. Now next time, in the next iteration, we begin at this and we'll try to scan the next smallest element. So here we find that 17 is the next smallest element, and we continue to swap it with 25, right? So at the beginning, now look at, after swapping, this is the position of our list. One is unsorted one, 8, 12, 17. This part is sorted one, whereas this is unsorted one. Okay, so here we continue with now next time again 29, and we found that 25 is the next smallest element. We'll swap it. So this process continues here. Okay, and this is 25 here. Now next time we begin with 32, and 29 is again the next smallest element, so it comes in the list, and this is how the complete procedure takes place. I hope you are following me. This is very simple example. You just have to understand the terminology behind, and this process continues till you get the complete sorted list. Okay, now here is the steps for selection sort. solve for the next smallest, swap the elements, okay, and then initialize this. Swapping this is finding the smallest element. The procedure for this is given here, okay. Now the time complexity for selection sort, in best case it is equal to the number of elements, that is On. In average case it is 2 times the number of elements, that is n square, and in worst case also you'll be getting it as n square. Okay, the next algorithm is insertion sort. So the basic idea is that take first element, one element, take the at the first time you have to select an element, iterate it through the sorted array. As the name indicates here, insertion sort. So you are inserting an element in, and they are sorted at the time of insertion only, right? So you are inserting an element in a sequence, okay, in a particular order of sequence. Now although it is simple to use, but it is not appropriate for large data sets, as the time complexity for insertion sort in the average case and worst case is equal to n square, where n is the number of elements. Now insertion sort is less efficient than the other sorting algorithms like heap sort, quick sort, merge sort. So insertion sort is less efficient, whereas we have more efficient algorithms like heap sort, quick sort and merge sort. That's why it is less preferable. It has got some advantages too. Simple for implementation, efficient for small data sets, and it is adaptive. Adaptive means it is appropriate for data sets that are already substantially sorted. Now here is the algorithm step. First, if the element is the first element and assume that it is already sorted, so you'll simply return 1, nothing doing here. Then we pick the next element and store it separately in a key. Now compare the key with the all elements in the sorted array. As the first element, at the first time we are inserting the element, we are assuming it as already sorted and we are keeping it in the sorted list. Next time we take the next element and store it as a key. Now we are comparing this key with the element in the sorted array, right? Will be compared. If the element in the sorted array is smaller than the current element, then move the next element, else shift the greater element in the array towards the right. And then insert the next value. And repeat this procedure until the array is sorted. To better understand, let us have an example. See here, we are assuming that the list is empty. We begin at the first element assuming 54 element is the first element and it is already sorted. Okay, so we simply insert it into the given list. See here, the shaded portion indicates that this is the sorted sequence list. Okay, sorted array list. So first time we inserted 54, then we switch to the next element, that is 26, and we compare. We stored this 26 into key. We compared it with the element in the sorted array. Since this is the first element here, and this is the only element at the beginning which is in the sorted array, so we compared these two elements and found that 54 is greater, so hence swapping will take place, right? Then next time we insert 93 into the element and we compared the all remaining elements here. Okay, we compared at the time of inserting 93 to the sorted list, we compared the remaining elements in the list. Okay, if it is found to be greater, then it will be inserted. If it is found to be less, then it will take the appropriate position after swapping the elements. Okay, next time we are inserting here element 17, we found the appropriate place. since it is less than 93, less than 54, less than 26, and it is also less than 26, so it will occupy the first position in the sorted array. Next time we are inserting 77. So this will be compared, will appropriate position is found, hence it is inserted. Then this is how the complete algorithm goes on. While insertion only, we are finding appropriate place for the item to be inserted. Okay, I hope you have understood this. Now the time complexity for this algorithm is uh, time complexity in the best case it is in, sorry, here it is selection sort, but it is actually insertion sort. So in average case, here we are having n square, and in worst case it is also n square. I hope you have understood this. So that's it for today. I will see you in the next class. Till then, take care. Have a nice time.